How do you get more useful work out of a given amount of fuel, and how do you minimize the emissions? Sometimes you're driving, you stop, sometimes you're driving very fast, sometimes you're driving very slow. So this puts a different kind of demand on the combustion system. Can you design in such a way that under all these conditions you have high efficiency? In our lab, we study ignition phenomena, and these are very rapid processes. To create conditions that will allow ignition, you also have to come up with a way to observe this ignition as it takes place. We have designed a reactor which creates conditions of high temperature and pressure, and they allow us to observe how long it takes for different kinds of fuels under different conditions to ignite. We had to figure out what part works, what part does not work, and I like to get my students involved in the process so they understand that when you're designing, you have many options. So there is no final solution, there is only a better option. Designing this system has been a fascinating and very interesting experience. My research is done in the Thermodynamics and Combustion Laboratory. This center is focusing on the environment, also focusing on energy. So the question is, how do you get energy and protect the environment at the same time?
People are becoming more worried about fuel efficiency and are dwindling energy supplies.
The most logical thing would be to transition the systems from operating on fossil fuel to renewable fuels. So what we're trying to do is to understand the burning properties of these new fuels. As we go forward, we will mostly be using fossil fuels, and eventually we want to be able to transition completely to alternative fuels.
We are trying to capture the relative ignition behavior of different kinds of furans to see which of them are the most suitable as an additive or a replacement for gasoline and spark ignition engines.
Spark plugs have been around for 100 years. They've reached their limit on the amount the technology is able to improve.
There is a possibility to replace that with a laser ignition system.
We have a high-power laser that gets focused by a lens, creates a plasma, and then the flame expands, and we look at density gradients between the flame and the surrounding cool gas. With laser ignition, you're able to ignite lean mixtures where you're able to use a lower amount of fuel and improve fuel efficiency. People do tests in single-cylinder engines, so it's been proven application-wise. It's just a lot more needs to be figured out on the fundamental side.
We have high efficiency, but at the same time we protect the environment, and we also produce engineers who will be able to carry out this work. Combustion systems are still going to have a significant role to play in the energy picture of the future.